So now you guys know how to create the equations for the linear programming model. We know a little bit what kind of problems you may encounter in linear programming. Let's look at one of the ways to solve the problem. Okay, so we're just creating the math now. You can actually with the math and do some try and error thing, and we're gonna see how to do that on Excel. But there's two ways that we're gonna learn about to actually solve how to get the actual answer for what is the optimal solution, how many amount of pipes one and amount of pipe two we should produce, or this product or that product. Okay, so the first way is the simple way. It's called the algebraic. Okay, and basically what you're going to do is you're going to just do some math and algebra there to find out what is the x1 and x2 that is equal into equations. Okay, so to do that, the problem have to tell you what intersection lies the optimal solution. Okay, so basically each constraint is understand as a line that limits our maximum amount in from those two decision variables. And then if you find the spot where they meet, that's going to be the optimal. If you know that, you're just using algebra to get to that spot, to that point. Okay, so let's take a look here. It's called algebraic solution. First, you need to develop the equation, of course. Then you're going to multiply one of the equations by a number, so that the coefficient of x1 or x2, if you add to the other equation, is going to be eliminated. Okay, and we're going to see how that works. And then what you do after you eliminate one of the variables, the x1 or x2, you can actually replace on that variable and find out one of the values, and then go back to the equation and find the other value. Okay, so again, a bit of an algebra there. We're going to also learn how to do with solver, and solver, it's an Excel add-in which will solve any case in any type of situation. But the algebraic one will help you in when you have a specific case of problems. Okay, so let's take a look at this problem here. Let's say that the straighten company, the one that we saw in the previous video, that have extrusion and packaging. We know that the optimal corner point is the intersection of extrusion and packaging constraints. Okay, so we know that the problem gave us that, right? And here we have the extrusion constraint and we have the packaging constraint. So the first thing, we substitute the equal or lower than to just equal. So now we have two equations, and we want to know the point where, sorry about that, they're both the same, right? That these two equations have the same numbers of x1 and x2. Okay, so you have to multiply. In this case, we multiply the second equation by 2. So it's going to be 2 times this, this, and this. So that's the value that is here, right? Multiply by 2 and subtract from the other one. So we decided multiply by 2 because then we will eliminate x1. See, 4x1 minus 4x1. So it's going to be 0x1. And then you're only going to have the x2. So if you only have one variable, we can isolate that variable and find out the value of x2. Okay, we could have multiply the first one or the second one by another number that will, let's say, 2 point or 3, right? If you multiply by 3, it would eliminate the x2, and we're going to have only x1. It doesn't matter. You have to eliminate one of them. Just choose the easy one. So we know that x2 now is equal to 6. Now I go back to that first equation here, and I'm going to use 6 here instead of x2. So it's going to be 4x1 plus 6 times 6 instead of x2 equals 48. And then just isolating x1, now I have the answer of x1. So I know that if going back to this equation, if I use, what was the value? It's 3 and 6, right? So if I use x1 equals 3 and x2 equals 6, it's going to be that data point that actually is makes this equation works, and this equation works at the same time. So it is the intersection between those two. And then I go back to the objective function. If you guys remember, it was $34 times x1 plus $40 times x2 equals to 342. So that was just the objective function. Okay. So again, these are the steps. I change the signal to equal to those two equations. I need to find out what the intersection is, what are the two constraints where the optimal point relies on the intersection. And then I take those equations, change to equal, find a number to multiply one of them so I can eliminate x1 or x2 off the equation, so add or subtract. Whenever I excluded x1 or x2, I find the value for the other x, 2 or 1, and then with that value I go back, find the value of the other variable, then take those two and put it in the objective function, and then woo, voila, you know the answer. Okay, that's great. Next, we're going to learn with Excel, and we're going to do that in class. Okay, so that's it for linear programming online. We're gonna do some more problems in class.